Welcome to Part 3 of the LS Electric PHOX DC Servo Quick Start from Automation Direct. In Part 1, we covered wiring and power-up of the drive and motor. In Part 2, we configured the software and jogged the motor. This video will focus on basic two-position motion of a lead screw-driven actuator using push buttons. Throughout this series, please refer to the Quick Start Guide available at AutomationDirect.com. It condenses key information from the LS manual into an easy-to-use format, while the full manual remains the best resource for detailed technical reference. For details on our system build and wiring, check out Part 1 here. For details on basic software setup, check out Part 2 here. Now we're ready to move into an actual motion application. For this demonstration, I've added a 3-position selector switch, a green illuminated push button, and 2 indicator lights, one red and one blue. The servo motor is driving a lead screw linear actuator with a 1/4 inch pitch. To use any type of hardwired control system, we need to connect the buttons, switches, and indicators to the drive's I/O breakout board. For this application, we'll be using 3 digital inputs and 3 digital outputs. Our inputs will be connected through DI1, DI2, and DI3, with DI-COM as the common. Our outputs will use DO1, DO2, and DO3, along with DO-COM. The drive requires external 24-volt DC power for both inputs and outputs, and we will use our control power supply. For the inputs, we're wiring them in a PNP or sourcing configuration. The positive side of our 24-volt supply connects to the DI-COM terminal. Each digital input channel on the drive then sources voltage to the contacts on the input device, which then connect to the common of the 24-volt DC supply. DI1 will come from the left position of our selector switch, DI2 from the right position, and DI3 from the green push button. For outputs, the drive uses NPN or syncing wiring. The positive side of our 24-volt supply feeds each indicator light, and the negative side of each light connects to one of the digital output terminals. The DO-COM terminal then feeds the common side of the 24-volt supply. DO1 will operate the red alarm indicator, DO2 the blue in-position light, and DO3 the green lamp on the push button for system homed indication. Now we'll move into the software setup using the Setup Wizard. We press the online configuration option to read the current parameters from the drive. Motor and encoder parameters remain the same as in Part 2, so we continue through the wizard until we reach the electronic gear ratio page. Our motor uses an 18-bit encoder, so there are 262,144 counts of motor resolution. Some motors have a 19-bit encoder, or 524,288 counts. Refer to the Quick Start Guide to find out which value to use for your specific motor. Rather than commanding positions with these large, awkward numbers, the software allows us to scale them into a user unit. Since our actuator moves a 1/4 inch per motor revolution, 4 revolutions equals 1 inch of linear travel. By setting the numerator of the gear ratio to our motor resolution of 262,144 and the denominator to 250, 1 complete motor revolution becomes 250 user units. And 1 inch of linear travel becomes 1,000 user units. This means each unit equals 1 mil, making our position commands much easier to work with. We continue through the wizard to the digital input configuration. We assign DI1 as the home start input, and DI2 as the first index select bit. The index select bit will act as a binary number. Having it off will select index 0, and having it on will select index 1. DI3 is the start signal, and DI4 will be used to enable the servo. We set it to servo on with a low true logic state so that the servo automatically enables when the drive powers up, even though we have nothing physically connected to that terminal. Next, we configure the digital outputs. DO1 is assigned to the alarm output for the red indicator. DO2 is set as our in-position signal for the blue indicator. DO3 is assigned to the system homed function for the green push button lamp. DO4 remains unassigned. For homing, we use a simple method. We manually jog the actuator to approximately the middle of its travel, and then we tell the drive to treat that current position as home. For this, we select homing method 35, called current position, and leave the remaining values at their defaults. There are many versions of homing, and this drive has a lot of different options in regards to how it homes and the information it needs to properly perform a home. Please refer to the user manual for a lot more detail on the various options. We write these settings to the drive, save to EEPROM, and cycle power. When the drive powers back up, the servo automatically enables, we hear the brake release, and we can begin jogging. Since DI4 keeps the servo enabled, preventing software control, we temporarily change it to high true logic so we can use the software jog. We set the jog speed to 1 inch per second, which equals 240 rotations per minute, and jog the actuator to the middle. Once centered, we disable the drive, restore DI4 to its low true state, and the servo re-enables. We can now set this middle position as home. Moving the selector switch to the left activates the home start input, and the system records the current location as 0. We see the green indicator light up indicating the system has been homed. Again, there are many other homing methods available for systems that need a collision home or sensor-based homing as well. Please refer to the manual for further details. Next, we set up our index moves. In the index editor, we adjust index 0 and index 1. Index 0 is an absolute move to 0 and then stop. Index 1 is an absolute move to 1,000 user units or 1 inch and then stop. Velocity, acceleration, and deceleration are all set to values of 1 inch per second and 1 inch per second squared. Anytime index information is changed, it requires a save to EEPROM if you want that change to survive a power cycle. After any changes, you can refresh the index data to ensure that your edits were accepted by the drive. We have saved these settings and are ready to select the right position. We press the push button, and it moves the actuator 1 inch to the right. Notice the blue in position indicator turned off as we moved, and then back on when we reach the new commanded position. Pressing the button again doesn't move anything because index 1 is an absolute move and the actuator is already at the commanded position. Selecting the middle position and pressing the button sends the motor back to the 0 position in the middle. Now let's switch index 1 from an absolute move to a relative move. After doing the edit, each time we press the push button, the system moves 1,000 user units, or 1 inch, to the right. We then move it back to home for the next run. We can also set a repeat count. If we change the repeat count to 3, a single button press will cause the actuator to move 1 inch 3 times in a row. We then move it back to home for the next run. Finally, let's create a more complex multi-step sequence. We configure index 1 to move 1 inch to the right and dwell for 1 second. Then automatically transition to index 2. Index 2 moves 2 inches to the left of home, dwells for 2 seconds, and then transitions back to index 0. Index 0 returns the actuator home and stops. We'll send that edit, save to EEPROM, refresh the index data to make sure all of our changes are there. When we activate the sequence, the system performs all these steps automatically. Right 1 inch, pause 1 second, left 2 inches past home, pause 2 seconds, and then back to 0. Perfect. Through these examples, we've demonstrated how to wire the PHOX DC servo system, configure it for basic jogging, perform homing, create absolute and relative index moves, use repeat counts and dwell times, and build multi-step sequences. all using a simple set of switches and a push button. If you need further assistance with your project, contact our free, award-winning technical support team. If you want to take a look at the PHOX DC servo lineup, click here. If you want to see more videos from Automation Direct, click here. To subscribe to our YouTube channel, click here.